Oh, I want to simplify this.
X.
No, not factoring actually. That's a great trap on this one. Nope, we can't do the derivative yet.
Square root of x. Yeah, make that.
Can't multiply. I don't want you to multiply by anything. Yes.
Separate
Separate fractions. Y is equal to x squared over root x plus 4x over root x plus 3 over root x. What is the square root of x? What power is that? X to the 2 over x to the 1/2 plus 4x over x to the 1/2 plus 3 over x to the 1/2. Now what can you write it as? What is x squared over x to the 1/2? X to the what power? 9? 3 over 2, you subtract. 4 times x to the what power? 1/2, and this is plus 3x to the what? Negative 1/2. Can someone now just tell me what the derivative of this thing is? Can someone tell me what the derivative of this thing is? Adam, tell me what it is. Look at the board and just tell me what it is. Nope. What do you bring to the front? This right here. 3 over 2 times x to the what? Yep. Plus 2x to the? Yep. Minus? Yep. Done. Done. Done, 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 done. Okay, so what's the variable in this one, by the way? What's the variable? Y. This is z in terms of y. So z in terms of y is going to be a times y to the what power? Negative 10 plus b e to the y. So z prime of y is going to be equal to equals negative 10a y to the negative 11 plus what? b e y. What's the derivative of e to the y?
e to the y.
What does the b do? Nothing. It just sits there. We learned this yesterday. d dx of e to the pony is equal to e to the pony. As long as pony is just a static single thing. Got it? It's still there. It's being multiplied right there. That's it. That's it. Nothing. Nothing other than that. Optimally differentiable. Yes? Well, hold on. Hold on. It's a e to the v plus
b v to the negative 1 plus c v to the negative 2.
yeah. And now you differentiate. Now you differentiate and you end with y is equal to va. No, oh, I did that wrong. What is it? It's just a e to the v, right? Do not do that. Minus bv to the negative minus 2cv to the negative. Done. Yes, go ahead. No, you got it? So what's the derivative equal to? 8x plus 4, correct? And what's the derivative evaluated at 1? 8 times 1 plus 4 is equal to 12. So the slope is 12 and the point is 1, 9. So what's the equation? Y minus is equal to 12 times x minus 1. Done. That's it. That's it. Done. We didn't have to use a limit. It's great. It's nice. T to the 1/2. So what's the derivative?
So it's 1/2 t
To the 1/2, yeah. Times 1 minus t plus the square root of t times, what's the derivative of the second thing? Nope.
1 plus 1 minus 1, so 0.
Nope.
Negative 1.
-1. What's the derivative of this right here? What's the rate of change of this? 0. What's the rate of change of this? -1. So what's the overall rate of change? -1. So does this simplify a little bit? Sure. It simplifies to 1 minus t over 2 times the square root of t minus the square root of t. Ah, hold on. What'd you say? Where'd the denominator come from? The denominator came from negative 1/2. So it goes down to the denominator. That's where it comes from. My question, though, is before today, if I gave you this right here and asked you, how do you find the derivative, what would you have to do first? If I asked you this yesterday, what would you have to do first? Multiply it out. So what does f of t equal if you multiply this out? Root t minus t times root t, right? So that's equal to t to the 1/2 minus t to what power? T to what power? 3/2. Why is it 3/2? Can someone explain why it's 3/2? Yes.
Because t is t to the 1.
It's t to the 1, and this is t to the 1/2. What's 1 plus 1/2? 3f. So now can we take the derivative? Yeah. What's the derivative now? 1/2 minus 3 over 2t to the 1/2. Are these going to be the same? Yes. They are going to be the same. Do they look the same right now? No, but are they the same? Yes, they are the same. They are the same. Yeah, go.
If they're t to the 1/2 minus 2 to the 3 over 2.
Yeah.
I cannot calculate them. No way to just.
I don't understand what you're asking.
So there's no way to calculate those two.
T is just a variable. So I don't understand what you're asking.
What she's saying is, why can't we like simplify t to the power of 1/2 minus?
Yeah, you could rewrite it if you wanted to. You could write it as 1 over 2 root t minus 3 over 2 root. Yes. So yeah, can you simplify this, kids? Can you simplify this, kids?
Yeah.
Okay. When I ask you a question, it's generally a good idea if some of you pretend like you're awake. Some of you. Considering you have nothing to twitch, draw, or do, speaking is what I'm aiming for here. 3 over 2. So yes, it would be 3 root t over 2. So yes, can you simplify it so they will look identical? Yes. Do I care at this moment? No, I don't. All I'm telling you is that just because you have the product rule doesn't mean you have to use the product rule. No, it doesn't. This is just a tool. This is just a tool. Just a tool. G of x. So what's the derivative of g of x? G prime of x. Congratulations. Times the square root of x. Good. Plus
G of x.
times 1/2 x.
To the negative 1/2.
Yeah, good. There it is, right there. What's the derivative of g? What is the derivative of g? G prime. What is the derivative of g? Good. Don't overthink this stuff. Please. I'm giving you little tiny pieces at once, and this is why you're going to run into difficulty if you think about it too much. What is the derivative of g? Done. What's the derivative of the square root of x? Oh, you did it right there. Good. So this is the derivative of f, because f is the product of two things. If you see the product of two things, what are you going to have to use? The product rule. So now it's asking you find f prime of 4. What do we plug in for x?
4.
So f prime of 4 is going to be equal to g prime of 4 times the square root of 4 plus g of 4 times 1/2 4 to the negative 1/2. Oh, did it tell us a bunch of this? G of 4 is 2. And then it also tells you that g prime of 4 is 3. So what does this turn into? It turns into 3 times 2 plus 2 times what? 1/2 times... What's 4 to the negative 1/2? That's 1 over the square root of 4, which is... 1 over the square root of 4 is 1/2, not 8. So that's 6 plus 2 over 4. So that's equal to 13 over 2. Just because something looks visually complicated doesn't mean it is visually... doesn't mean it actually is complicated. No, it does not. It does not. So let's say, Julia, I gave you this right here. Let's say I told you n of x was equal to, let's say m is a bad one. Let's say r of x times, let's say j of x. If I asked you, what is the derivative of n? What can you tell me, Julia? What is the derivative of n?
R prime
Times,
times j prime.
nope, plus,
Oh, okay.
plus,
Rx
times.
then the j prime.
Yes,
Okay,
correct, done.
Okay.
Do you ever do the derivative of both and multiply them? No, that's the first thing I showed you. No, 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 no.
Dot your J's.
Yeah, dotting my J's is dangerous in this, isn't it? I'm not going to dot them because there's the prime. Okay, so now you've learned, what rule was this called? This is called the product rule. So what do you think is next?
Division?
Division, yeah, what's that called?
Scary. Aw, it has a big name.
Kids, quotient rule. Okay, so a quotient is two functions being divided by one another, right? So we're talking about what is the derivative when you have f of x divided by g of x? Well, to do that, let's say we wanted to use limits, we would have to write the limit as h goes to 0 of, ready? F of x plus h, stop twitching, Molly, over g of x plus h minus what? F of over all over h. Can you play around with that a whole bunch?
Yeah.
Yeah, you can. If you look it up in your book, which you totally can do, you can look this up in your book, and you end up with something that looks like this. Whee! Yay! It goes, brrr, nope, this is the only way to do it. It collapses really nicely. And once again, guys, just because it looks long doesn't mean it's difficult. No, you can look at this step by step. Each of these steps is really easy. It's just a lot of really small steps. This is what it comes down to, and this is where it's really, 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 really important you understand what's going on. And you have to memorize this. This is, again, super, super, super important. This is the quotient rule. If you take the derivative of the quotient of two things, see this right here? That's the derivative. You can skip over this. It goes straight to this. And it looks like that's hard to remember. This means g times the derivative of f. And this means f times the derivative of g. This is what I need you to remember. F over g. F is going to be called the high function. And this one's going to be called the low function. The way you remember this is the simple phrase low d high minus high d low over low squared. That's all you remember. What is low? Low is g. D means derivative. Again, so what does low d high mean? It means the low function times the derivative of the upper function minus the high times the derivative of the low function all over low squared for some reason, but we'll talk about it anyway. It says find an equation of the tangent line to that curve at that point. We have the point, so what do we need? Need slope. That's it. We need the slope. How do you find the slope at that point? You find, what do you find first? And then you evaluate it at what? What do you evaluate it at? 1. Exactly. You evaluate it at 1. Evaluate it at 1. So the derivative is a quotient. So what are we going to use? Yeah, we can't really simplify that, so we have to use the quotient rule. So y prime is going to equal low 1 plus x squared. What's the derivative of the top?
It's e.
Yeah, e to the x. You got to say to the. You got to say e to the x. Minus low d high minus high. Hunter, what's the derivative of the bottom? Hunter. Hunter. Yes. What's the derivative of the bottom?
It's just like...
What's the derivative of that? What is it? Yes. All over what?
What's it still name?
Yep. Unsquared. Squared. Low d high minus high d low over low squared.